Hello and welcome to the first in a series of videos on simultaneous equations. So in this video I'm just going to give you an introduction to what simultaneous equations are and the different ways we can solve simultaneous equations. So the first thing I would like you to do is just have a look at this equation in blue and think about, can you solve this equation? So we've got 6x plus y equals 18. So can we solve this equation? Now the answer to that is no. And the reason for that is because there are actually an infinite number of solutions to this equation. Okay, there's not just one value for x and y that would work. There are an infinite number of values. So for example, let's say x equals 2. Well, to work out the corresponding value of y, we can just substitute 2 into our equation. So it's going to be 6 multiplied by 2 plus y equals 18, and 6 times 2 is 12, so it's going to be 12 plus y equals 18, and now if we subtract 12 from both sides, we're left with y equals 6. So when x equals 2, y equals 6. But notice that's not the only possible values we could use. We could use any value for x. So for example, let's say what happens when x is equal to negative 20. Well, when x is negative 20, again, to work out the corresponding value for y, we can just substitute negative 20 into our equation. So it's going to be 6 multiplied by negative 20 plus y equals 18. 6 times negative 20 is negative 120. So we've got negative 120 plus y equals 18. And now if we add 120 to both sides, we are left with y is equal to 138. So when x equals negative 20, y equals 138. And like I said, there are an infinite number of values for x and y we can use. So we cannot solve this equation. So in order to find what the exact values for x and y are, we need two equations. And that is what simultaneous equations are all about. So now notice we've got two equations with two unknowns. So with this information, we are now able to solve this pair of simultaneous equations. Now when we're solving simultaneous equations, there are two methods that we can use. There is the elimination method and the substitution method. Now in this video I'm just going to focus on the substitution method, but I will go through the elimination method in a future video. So the reason why it's called the substitution method is because what we're going to do is we're going to substitute one equation into the other. So what I need you to do is focus on this equation here. Notice it says y equals x minus 17. So these two things on either side of our equal sign are exactly the same. So what I can do is I can substitute x minus 17 into our original equation where y is. So what I'm saying is, instead of writing y, I can write x minus 17 because they are exactly the same thing. So let's rewrite our first equation, and I'm just going to replace y with x minus 17. So we've got 6x plus, now again, instead of writing y, I'm going to write x minus 17, because they are exactly the same thing. And we know that equals 18. And now we've got this equation here, we've only got one variable to calculate, so we can solve this equation. So 6x plus x, that gives us 7x. So we've got 7x minus 17 is equal to 18. And now if we add 17 to both sides, we're left with 7x is equal to 35. And now if we divide both sides by 7, we get x is equal to 5. So I found my value for x, but we can't just stop there. We need to find the corresponding value for y. And to do that, I can use either one of these equations. It doesn't matter which one I use. So I'll use the bottom one because it looks a bit easier. So now what I'm going to do is I'm going to substitute my value for x back into my second equation. Okay, so instead of writing x, I can write 5. So let's do that over here. So to work out our value for y, it's going to be y equals, instead of x, I'm going to write 5. It's going to be 5 minus 17. Well, 5 minus 17 is negative 12. So we have our values for x and y. And let me just show you that it doesn't matter which equation we use to substitute our value for x into. So let's also substitute it here, just to show you that you should also get exactly the same answer of -12. So let's do this in a different colour. So let's use this equation now. So we've got 6x, and again, instead of writing x, I'm going to write 5. So it's going to be 6 times 5 plus y equals 18. So 6 times 5 is 30. So we've got 30 plus y equals 18. Now to get y on its own, if we subtract 30 from both sides, we're left with y equals -12. So we get exactly the same answer. Okay, so we're going to go through another pair of simultaneous equations that we're going to solve. Now, before I go through this, I encourage you to pause the video and see if you can solve these equations yourself first using the substitution method. Okay, so let's go through it together now. So I can see here that y is equal to 2x. So in my second equation, wherever I see a y, well, I can just replace that with 2x because I know that they're exactly the same thing. So what I'm going to do is I'm going to rewrite my second equation, but instead of writing y, I'm just going to replace that with 2x. So we've got 4x plus, and again, instead of writing y, I'm going to write 2x, and we know that equals 18. And now I can solve this equation because we've only got one variable. So if we just simplify 4x plus 2x, well, that gives us 6x. So 6x is equal to 18. And now if we divide both sides by 6, I get x is equal to 3. So my value for x is 3. Now to work out the corresponding value for y, I can just substitute this back into one of my equations. And I'm going to choose the first equation because it looks a bit easier. So let's do this in a different colour. So our value for y, well, it's just going to be 2 times x. And I know x is 3, so it's just going to be 2 times 3. Therefore, y is equal to 6. So I have my values for x and y. When x equals 3, y equals 6. And if I'm not going to do this, but you can just plug these numbers into your second equation just to make sure they work too. Okay, so pause the video and have a go at this one here. Okay, so in this one, I can see that y is equal to x minus 3. So in my second equation, wherever I see a y, well, I can just replace that with x minus 3. So let's rewrite our second equation. We've got, start over here. So we've got 2x plus 4 times y. So instead of 4 times y, I'm going to write 4 times x minus 3. Now I need to put my x minus 3 in brackets. Okay, so it's not 4 times x and then minus 3. It's 4 times this whole thing. So it's 4 times the expression x minus 3. And that is equal to 42. So we've got our equation now. So we just need to solve this. So because we've got brackets, let's expand the brackets. So we've got 2x, and then 4 times x is plus 4x. And then 4 times -3 is -12. And that equals 42. So now if we simplify this part, 2x plus 4x is 6x. So 6x minus 12 equals 42. And now if we add 12 to both sides, we get 6x is equal to 54. And now finally, if we divide both sides by 6, we get x is equal to 9. So we have found our value for x, which is 9. And now we can substitute this value for 9 back into our, let's use our original equation. So always pick the equation that's easiest, just to help yourself out. So if we use our top equation, we've got y is equal to x minus 3. So instead of writing x, we know the value of x. So that is just going to be 9 minus 3. Therefore, y is equal to 6. So when x equals 9, y equals 6. Now I'm going to stop there for this video. But in the next video, we're going to get lots more examples of solving simultaneous equations using the substitution method, and then after that video I'm going to go on to using the elimination method. So hopefully you found that useful, and hopefully I will see you in part 2. Take care.